हॅलो फ्रेंड, आज आपण टायट्रेशन ऑफ वीक ॲसिड अगेन्स्ट स्ट्रॉंग बेस हा कन्सेप्ट स्टडी करणार आहोत. ह्याच्या पूर्वीच्या व्हिडिओमध्ये आपण स्ट्रॉंग ॲसिड वर्सेस वीक बेस कन्सेप्ट आपण स्टडी केलेला आहे आणि त्याच्यावरून की जो कन्स्ट्रक्शन कर्व ॲज वेल ॲज त्याचे पी एचचे चेंजेस आहेत डिफरंट स्टेजेसला असणारे ते आपण कॅल्क्युलेट केलेले आहेत. आजच्या लेक्चर्समध्ये आपण की कन्स्ट्रक्शन ऑफ टायट्रेशन कर्व हा पॉईंट स्टडी करणार आहे. त्याचबरोबर की जे एक्झाम्पल्स आज आज आपण घेतलेलं आहे ते एक्झाम्पल्स आहेत वीक ॲसिड वर्सेस स्ट्रॉंग बेस. द वीक ॲसिड in the titration of weak acid against strong base. In this, the titrant is strong base. Strong base like NaOH and weak acid, that is titrant, it also known as analyte, is weak acid that is acetic acid CH3COH. The term weak acid refer to the monobasic acids, that is the dissociation in aqueous solution to an significantly less than the 100%. The typical example being as acetic acid, formic acid, hydrocyanic acids. These are the examples of weak acid. With acetic acid, the neutralization reaction can be represented as the reaction, that is acetic acid CH3COH reacted in presence of the strong base like NaOH. From this neutralization reaction, here there is formation of Na plus ions and OH minus ions. Again there is formation of H plus ions and CH3CO minus ions to form, this is a reversible reaction. It gives formation of CH3CO minus Na plus ions plus H2O. Now from this neutralization reaction, at the beginning of the titration, there is only acetic acid will be present in the conical flask. Therefore, the pH of the solution can be calculated from the concentration and dissociation constant of the only acid molecules. As soon as the titration is started, the sum of the acetic acid is converted into sodium acetate and the buffer system is set up. The concentration of acid decreases whereas that of the salt formed will increase and the pH slowly increases. By calculating concentration of unneutralized acid and that of the salt formed, the pH can be calculated up to the equivalence point. At the equivalence point, a solution of sodium acetate, that is CH3CONA, will be present. Due to hydrolysis of the salt, the solution at the equivalence point will be alkaline or pH will be greater than the 7. The exact pH value can be again calculated by considering the hydrolysis constant of the salt and the concentration of the salt formed at the equivalence point, that is CH3CONA plus H2O. The greater the concentration at the higher the pH, as excess a strong base in which is added beyond the equivalence point. The pH is determined only by the concentration of excess hydroxyl ions. Accordingly, the titration curve beyond the equivalence point follow that for the titration of the strong acids. Consider the titration of consider the titration of 10 cm cube of 0.1 molar acetic acid with 0.1 molar NaOH solution. The pH at the various stages can be calculated. For the pH calculation, here the Ka for acetic acid CH3COH will be 1.8 into 10 raised to minus 5. Therefore, at the beginning of the titration, we can calculate the pH of the solution. At the beginning of the titration, pH can be calculated. Since the acid is a monoprotic acid, its dissociation can be represented as, here the dissociation constant of acid CH3COH, which can dissociated to form CH3CO minus plus H plus ions. Here, suppose the alpha is a degree of dissociation and capital C is molar concentration, then the concentration like CH3CO minus ions acetate ions is equal to concentration of H plus ions will be alpha into C, and the concentration of CH3COH, here H, is equal to 1 minus alpha into C. Therefore, the dissociation constant that is Ka of weak acid is given by now these are the dissociation constant of weak acid, that is the Ka, the concentration of acetate ion into concentration of H plus ions is divided into concentration of acetic acid is equal to alpha into C divided by 1 minus alpha into C. Here C will get cancelled with each other to form the alpha square C divided by 1 minus alpha. Now for acetic acid, the Ka value is 1.8 into 10 raised to minus 5. For acetic acid, K value is given. Therefore, the 1.8 into 10 raised to minus 5 is equal to alpha square C divided by 1 minus alpha. Since alpha is very small, that is the 1 minus alpha is equal to 1, and here therefore 1.8 into 10 raised to minus 5 is equal to alpha square C. Therefore the alpha is equal to under root 1.8 into 10 raised to minus 5 divided by C. Now the concentration of H plus ions is equal to alpha into C. Therefore under root the 1.8 into 10 raised to minus 5 into C. Therefore for 0.1 molar solution, the concentration of H plus ion is equal to 1.8 into 10 raised to minus 5 into 0.1. Therefore it will get 1.342 into 10 raised to minus 3. Now the pH is equal to minus log to the base 10 the concentration of H plus ions will be the minus log to the base 10 into 1.342 into 10 raised to minus 3. Therefore the pH of the solution will be 2.87. At the beginning of the titration, the pH of the acid solution will be the pH of the solution is 2.87 at beginning of the titration. Then if the 2 cm cube of NaOH has been added into the solution of weak acid, at the second condition, suppose the 2.0 cm cube of strong base, that is NaOH, will be added into the acetic acid solution of the conical flask. Then here the acetic acid will be neutralized to form a salt, that is sodium acetate, and the 8.0 cm cube of acetic acid will remain unneutralized, and the total volume of the conical flask solution will be 12.0 cm cube. At the beginning of the titration in the conical flask, there is only acetic acid is present, that is the 10 cm cube of acetic acid is present in the conical flask. At the second condition, if a 2 cm cube of NaOH is added into the solution of acetic acid, that is CH3COH solution, therefore from the 10 cm cube of conical flask, out of 10 cm cube, the 2 cm cube of acetic acid solution will be neutralized, and from the total 10 cm cube, there is 8 cm cube of solution will be unneutralized condition. Therefore the total volume of the conical flask solution is 10 cm cube. At this condition, the pH of the solution can be calculated from concentration changes and pH changes of the solutions. The total volume 12 cm cube, therefore the concentration of salt is equal to, there is addition of 2.0 cm cube having concentration 0.1 is divided into total volume, that is 10 plus 2, 12 cm cube, and for acid, concentration of acid the out of 10 cm cube, there is 8 cm cube solution will remain unneutralized, therefore 8.0 cm cube into having the concentration 0.1 divided by total volume, that is 12 cm cube. Now the system is a mixture of weak acid, that is acetic acid, and the salt of sodium acetate, and is an acidic buffer. The pH of an acidic buffer is given by expression, that is the pH is equal to pKa plus log of concentration of salt into concentration of acid. At the 25 degrees Celsius temperature, the pKa will be minus log 1.8 into 10 raised to minus 5, and the salt concentration of salt into divided by concentration of acid will be 2.0 into divided by 8.0. The substituting this value into the above equation, it will get the pH is equal to 4.74 plus log of 2.0 divided by 8.0, it will get the 4.74 minus 0.602. Now it will get the pH of the solution is 4.14. When the addition of 2 cm cube of strong base into the 10 cm cube of conical flask weak acid solution, at this condition the pH of the solution will be 4.14. Now these are the, you can calculate the pH of the solution when the addition of strong base into the weak acid, that is 5.0 cm cube at this condition, and at the vicinity condition, that is addition of 9.9 cm cube of strong acid into the weak strong base into the weak acid solution. You can calculate the pH for both addition, that is 5 cm cube addition and 9.9 cm cube addition, and then send answer of this problems.